Hi there, folks. Today we're looking at inequality symbols and graphing inequalities. And we've already talked a little bit about inequalities. We've used those to try to show two values side by side and determine which one is bigger. Remember, the alligator eats the bigger value. But now we're going to talk about these inequality symbols in a little bit more of a broad sense. And, the idea that, we look at one of these as a less than and one as a greater than, but it's really more about which way you're reading it, okay? And so inequality symbols, remember the symbols that we see here are read as less than or greater than. And again, it really depends. We typically think of this first one as a less than symbol, but that's only because we read left to right. Okay, it's kind of about which end you run into first. If I run into the pointy end first, the smaller end first, then I call it a less than symbol. All right, if I run into the bigger end, the mouth end first, then I call it a greater than symbol. So kind of consider it, think about it this way. If I have a what we consider to be a less than symbol, if I'm reading right to left, if I'm reading in this direction, I run into the pointy end first, so that's a less than. But if I were to read this thing backwards, if I were to read in this direction, you see I run into the big end first. All right, so if I'm reading it backwards, I would call this thing a greater than symbol. All right, and it's one of those kind of strange things that we always call this a less than symbol because, well, that's typically the way we read it. All right, because we read left to right. But keep in mind, it benefits us sometimes to read this thing backwards or forward. So just think about that a little bit, and we'll talk about that a little more detail and how that allows us to rewrite some of these things and read them appropriately. Okay. The second piece of this is when I have that little line underneath, we add that equal to condition. So if I have the inequality with a line underneath, it's less than or equal to or greater than or equal to. And the same thing applies. If I read this backwards, all right, I might call it a greater than symbol instead of a less than symbol. So kind of think about it that way. For example, if I look at something like this, these guys, I just want to kind of reiterate these in terms of words. If I'm reading from the perspective, and when we look at these, we want to read it in terms of what the variable is. So like in this first one, I would read from where the variable is, and I would read this way and say, okay, n, and then I run into the pointy end, so n is less than or equal to 8. So as I kind of read this thing, I would say that n is less than or equal to 8. Okay, and that's kind of the way I would read this thing. The next one, same kind of thing. I see the x value, so I read left to right. So I start with the x, and as I move across, I run into the mouth end first of the alligator, so I read it as a greater than symbol. So I say x is greater than the 7. So again, x is greater than 7 this time. All right. But if I look at this next one, again, if I want to know about x, I should start reading from where x is. So if I kind of started here where x is, I would read this thing backwards. So I'm actually going to start here with x, and I'm going to read in this direction. And if you kind of work your way across reading in that direction, you see the x, and then you run into the mouth end of this thing. So I read it as x is greater than 7. Okay? And so just keep that in mind. The only reason we typically consider this guy less than symbol is because the perspective we're reading it from. This one would actually be x is greater than 7. And really, the last two inequalities we just looked at, these are the same inequality. All right, when I look at these, that first one and the next one are saying the same thing. Notice the alligator is eating the x both times, and it's comparing to the 7. So we would read them the same way. And if you read from the perspective of x, you would say x is greater than 7. All right, same thing with this one, x is greater than 7. With this one, you might read it as 7 is less than x, okay? But that doesn't help us understand what x really is. Okay, by saying x is greater than 7, now we know x is bigger than 7. So x's value is like 8 or 9 or 10. When I say 7 is less than x, well, that confuses us, and we're not really sure which values we have for x when we read it that way. Okay, so we want to read from the perspective of x. And one of the things that can become helpful is if we rewrite the inequality so that it makes sense to read it left to right. So like this one, if I were to write the x first, just make sure the alligator's eating the same thing. So here the alligator was eating the X. So down here, when I write it, the alligator should still be eating the X and then the 7. Okay? And now we can see it's the same as the one before it. Okay? And so sometimes it's a great idea to rewrite this thing so that it's easier for us to read, so we can read left to right. For example, if we look at the next one, let's rewrite it. Let's rewrite the Y first, and then look at the alligator. The mouth is eating the Y, so I keep it eating the Y. And then the -5. So now as I read left to right, it's much easier to read this way. I would say that Y is greater than or equal to a -5 this time. Okay? So again, that idea of where is the variable, which way should I be reading this thing, and should I rewrite the inequality to make it easier to read? Okay, that's how these symbols work. And I think there's a misconception that it's always a less than symbol. Like this guy, I have to read this as 7 less than X. Well, it doesn't make sense to read it that way. It makes more sense to flip it and say X is greater than 7. Okay, now we have a better understanding of which X values we can use. Okay? So for each of these, let's rewrite them in the format that makes sense. Let's rewrite them so we can read it left to right like we're supposed to. So this one, I want the A to be over here. So think about which way this inequality symbol has to face in order for it to still be pointing the same direction in terms of A versus the 2. In the original, the alligator's eating the 2. So in this one, the alligator should still be eating the 2. And see, now that's easier to read. It's A is less than or equal to 2. And if I had read the original backwards, it would still say A is less than or equal to 2. Okay? If I rewrite the next one, again, it's T. The alligator was eating the T, so I make sure it's still eating the T. So now it's T is greater than -4. And again, if I had read the original backwards, it would say the same thing. T is greater than -4. The next one, again, I want to start with the C, so I put the C down. And now think about which way that thing is pointing in regards to the C. The little n should be at the C. The alligator should be eating the 9. So its C is less than 9. And if I read the original backwards, that's what it says. And then the last one here, again, I want to start with the K. So I put the K value first. And then I say, okay, the alligator's eating the K. I want it to still be eating the K. So K is greater than or equal to -3. And again, that's the same thing as what I would get if I read this thing backwards, okay? So that perspective is really important, all right? And we want to write things in terms of the variable. We want to understand which values the variable represents, all right? So I write it as K is greater than or equal to -3 instead of -3 is less than or equal to K. That doesn't make much sense, okay? Let's talk about this in terms of statements here. So write an inequality for each statement. So this one says you can have 10 M&Ms or less. All right. So think about what that means. So I'm going to use the variable M for M&Ms. And let's think about which values I'm allowed to have for M. It says I can have 10 or less. So that means the M values can be equal to 10 or they can be smaller than 10. So I would say that M has to be less than or equal to 10. Because that's what that inequality means. It means I could have 10 or I could have less than that. Okay? If I look at the next one, it says I'll give you at most $20 for your work. So I'm going to use W for work. All right? It says at most $20. If I said I'm going to give you at most $20 for some job, it means that you're not getting any more than that. You'll get $20 or you'll get less than that. Maybe you didn't do a great job. So if you do the best job, you'll get $20. If you do anything less than that, you'll get less. And so when I think about that from that perspective, it's a less than symbol or equal to $20. See, the most you'll get is $20, so it's $20 or less. So W is less than or equal to 20. Okay? Next one said we need at least 8 people to sign up. Okay, so I'm going to use a P for people. And it says I want at least 8 people, so I need a minimum. The smallest I could have is 8, or I could have more. So think about that from the perspective of inequality. That means it's greater than or equal to 8. Okay, so I could have 8 or I could have bigger than 8. I could have 9 or 10 or 12, all right? All right, as long as I have a minimum of 8. And then this one, once the pressure drops to 5 psi, the balloon won't float anymore. Okay, so I want my balloon to float in the air, and eventually the pressure starts to drop, some of the helium leaks out, and it sags to the floor, and it makes us all sad. All right, so I'm going to use B for balloon here. And it says once it drops to 5 psi, so anything below 5 psi, this thing's not going to float. So I want to be above that, right? I want to have a greater value, so B is greater than 5. And notice there's no equal to condition this time, because once it hits that 5, the thing's going to start to sink, okay, according to this problem. I don't know if the science supports that, so don't quote me on this, okay? But we want the psi, we want the pressure to be higher than that, greater than that 5, so that the balloon is floating. Okay? So now I want us to think about this from the perspective of a graph. And we've been talking about which values work. Now what we're going to do is we're going to convert that to a graph. And essentially the graph is just us shading where the values we want are. Okay? So when we talked about, the example of, 10, at the most 10 M&Ms or 10 M&Ms or less, the values I'm looking for there are 10 or 9 or 8 or 7 or 6. Okay, and we can understand that when we read that in that context, but now we want to show that on a graph. And so mathematically, here's what we do, all right? The first thing we do is we use an open dot versus a closed dot. Because again, when we're representing which values we want, we're using shading to represent that. And when you think about an open dot, it basically means, hey, there's no shading here. It's empty. I haven't shaded in that point, which means there's no equal to condition. It means that point doesn't quite count, all right? We can't use that one. It's not part of the shading, all right? But a closed dot is like I drew a circle and then shaded it in. So that indicates that we can use that value. That's when we have an equal to condition, okay? And so the two differences here, this one is open, so not shaded in means that point doesn't get counted. And then shaded in, all right, that's a closed dot, means that point does get counted, all right, because it's part of our shading, okay? And then from there, we shade one side of the graph or the other. So I use more shading. I color in the side of the graph that has the values that I want, okay? For example, if I look at something like this guy, it says x is less than or equal to -4. And so if I think about this from the perspective of a number line, so I'm going to draw the number line here. And I'll put 0 over here somewhere. And I'm just going to fill in these values. Okay? And so as I look at this thing, if I think about less than or equal to, that means that I could have a value -4, or I could have smaller values than -4, like -5, -6, -7. And so what I do on the graph to shade this thing, and you can do it on the graph right here if you want, I put a shaded dot right there on -4, because that's showing me, hey, that point counts. I'm going to shade that value in because it's part of my answer. It's part of the values I'm allowed to use. And then I want to shade where the rest of the answers are. Well, that was over here. It was the smaller values, okay? -5, -6, -7, -8, okay? And I put a big arrow on this end to say, hey, that keeps going, okay? If you don't like shading on the line like that, that's okay. What some students will do is they'll do like an open dot up here, and then they'll draw their shading like this, okay? And I think that's one of the things that confuses us as we start to graph these things, is we see these like weird lines up above. Again, that's just shading, all right? It makes more sense to put it on the line, but sometimes that's hard to see. It's hard to read, okay? So we want to shade these things, okay? If I look at the next one, again, I'm just going to draw this. So let's see, like -1, 0, 1, 2, 3, 4. And it says greater than 4, greater than 1. If I knew how to read, that would be great, right? So greater than 1. So should I shade 1? Does 1 count? Well, no, because there's no equal. It says I can't. It's not saying that I can equal 1, so I do an open dot now at 1. Okay? It's saying, hey, I can get as close to that point as I want, but I can't actually use that one. It's not part of my shading, so I'm going to leave it open. And then greater than means bigger values, so that's values like 2 or 3 or 4, so I shade this end of the line, okay? I shade where those values are, okay? If I look at the next one, it says less than -3. So again, I'm going to draw my number line. That was a very straight line I've just drawn. Oh, not very good. -2, -3. And this time it says greater than -3. So if I draw an open dot, because there's no equal to condition, all right? So I basically say, I'm not going to shade that point because I can't equal -3. But now it says x is less than -3. So less than means smaller than, so all the values below, so like -4, -5, so I shade this way, okay? And I put my arrow on the end, all right? If I look at the next one, again, I'm going to draw this thing, and I just include a couple values. I got to make sure 5 is on there, so maybe I'd do something like 2, 3, 4, 5, 6, something like that, okay? And so I'm just using a piece of the number line. I understand the number line keeps going and zero's down there somewhere, and a million is up at the top somewhere, okay? But we're just drawing a piece of the number line so that we can see where the shading goes, okay? This time I've got an equal to, so it's not just an open dot, it's a shaded in dot. I'm going to shade in that point because I can equal the -5. That gets part of the shade. That gets part of the shaded region now. And now I want greater than, so the bigger values. So I shade everything over here. Okay? And again, it's just a visual representation. See, we've talked about what this means. X greater than or equal to 5 means it could be 5 or 6 or 7 or 8. But now I'm filling in those other values. And now I get some extra values like 5.5. Okay, that maybe we didn't consider before. We can see that now in the shaded region. When we think about greater than, we think about the 6 and the 7 and the 8. But what about 6.1? What about 6.2? Well, now we can see those are included because I shaded those. Okay? Here's where some things might fall apart on us. We have to be a little bit careful here. This one's not written the way we want it to be written. Okay? And if you look at something like this, the most common mistake here is students shade the wrong side because we're reading it wrong, okay? This is when we should be reading backwards. And so if you look at something like this guy, let me fill some of these in. If I was reading it the way it's written, that says x is greater than or equal to -1, okay? And again, students will shade the wrong side on this because they're not reading it backwards. And so the first thing you might want to do here is let's rewrite it. Let's rewrite it as x, and then keep that symbol eating the right thing, so the alligator keeps eating the x, and then the -1. So when we rewrite it that way, now things become a lot easier, okay? So x is greater than or equal to -1. Now it's much easier to see that right here, there's a shaded dot here because I want to shade that in because it can equal that. But now I want the bigger values, so I'm going to shade everything to this side. Okay, so rewrite it from the proper perspective first and then do your graph. Okay, this guy, same kind of thing. And again, I just include a couple values. I just have to make sure the 3 is included there. And now there's no equal to condition, so I need an open dot. But now once again, this is not written the way I like it to be written. So maybe rewrite it first. X and the 3, and the alligator was eating the 3, so I got to make sure it's still eating the 3. So now if I read this properly, it says x is less than 3. So that means I'm shading the values that are smaller than 3, below 3. Okay? And so again, always rewrite these things so that it makes more sense as you go to graph it. Okay? The most common mistake here is we shade the wrong side. And we shade the wrong side because we're not reading this thing backwards like we should. So write it the proper way, and now we can read it a little bit more easily than we could have before. Okay?